To solve a trigonometric equation, we use the rules of algebra to isolate the trigonometric function on one side of the equal sign. Then we use our knowledge of the values of the trigonometric functions to solve for the variable. If you're not familiar with the values of the trigonometric functions, I would suggest using a unit circle to help out until you feel more comfortable not using it. So here we're going to solve the equation on the interval 0 to 2 pi. Now what makes this different from others is because of what's inside the argument for our trig function. It's not just an x, it's 3x. We started off solving it the same way, but at the end is where we veer off and do something a little bit different. But let's start by solving for sine 3x. So I'm going to add 1 over and get this. Then I'm going to divide the 2 over, and I'm going to get sine 3x equals a half. Now where does sine 3x equal a half? No idea. But I do know where sine x equals a half on the unit circle between these two intervals. And I know that sine x equals a half at pi over 6 and 5 pi over 6. So that's easy, but that doesn't really help us too much because we need to solve for sine 3x, not sine x. So what we got to do is we're going to set both of these equal to what's inside the argument, which is 3x. But we also have to find all the values that work. So we're going to start off with kind of like the general form of what the answer would be here. So we can say that 3x equals 2 pi over 6 plus 2k pi, where k is just some integer. And we use 2 pi or 2k pi because the period is, for sine, 2 pi. But I'm also going to do the same thing for 5 pi over 6. So I'm going to divide it here. 3x equals 5 pi over 6 plus 2k pi. Now here are these two. Now I'm going to solve for x on each one. So I'm going to start off with this. I'm going to divide both sides by 3. And I'm going to end up x equals pi over 18 plus 2k pi divided by 3. So I now know what x is, and now I'm going to do the same thing here, divide by 3. X equals 5 pi over 18 plus 2k pi over 3. Now I can actually go and find what each one, well, using each one I can find all the answers that solves this equation. Now remember, I have to be between 0 and 2 pi. So first thing I'm going to do, I'm going to let k equal 0. And when I do that, I'm going to get x equals pi over 18. Then I'm going to let k equal 1. And when I do that, I'm going to get x equals 13 pi over 18. K equals 2. Plug that in, and I'm going to get 25 pi over 18. Not too bad. Let k equal 3. And I am going to end up with x equals 37 pi over 18. Now 37 pi over 18 exceeds 2 pi. So I can actually just remove this and say that these three are the solutions for this part of it. Now I'm going to do the same thing for this side. Let k equals 0. And when I plug in 0 here, I'm going to end up with 5 pi over 18. Let k equal 1. Plug it in, I'm going to end up with 17 pi over 18. Let k equal 2. Plug it in, and I'm going to get x equals 29 pi over 18. And let k equal 3. And I'm going to end up with x equaling 41 pi over 18, which, again, 41 pi over 18 exceeds 2 pi. So I can just discard this. And these would be my 3 answers from this one. So these are my 6 solutions that are within the interval of 0 to 2 pi. Now I'm going to do it again for this one, except the interval is from 0 to 4 pi. And I have root 3 tangent x over 2 minus 1 equals 0. I'm going to do the same thing. I'm going to solve for tangent. So I'm going to add 1 over. Root 3 tangent of x over 2 equals 1. Divide the root 3 over. And I'm going to get 1 over root 3. And if you're not familiar with that on the unit circle, I'll just rationalize it and I would get root 3 over 3. Now that's where tangent x over 2 equals. And I have no idea where that is on the unit circle, but I do know where tangent x is equal to root 3 over 3. And I know that is at x equals pi over 6. And I say only pi over 6 because of the period for tangent being negative pi over 2 to pi over 2. And this is the only solution on this interval. Now, I still need to solve for where tangent x over 2 is. So I'm going to take my pi over 6, set it equal to x over 2. So x over 2 equals pi over 6, but not forgetting that tangent has a period of pi between negative pi over 2 and pi over 2. And I want to get all the solutions that exist on 0 to 4 pi. So I'm going to start off with the general solution. So plus k pi, where k is an integer. And then I solve for x by multiplying the 2 over. So x equals pi over 3 plus 2k pi. And this is only one general solution I have. So I am going to figure out all the solutions by starting off with k equaling 0. And when I do that, I'm going to get x equals pi over 3. Now I'm going to do k equals 1. And when I plug 1 into x here, I'm going to end up with x equals 7 pi over 3. Now I'm going to let k equal 2 this time. And when I add or put 2 in here for k, I'm going to end up with 13 pi over 3. But that, nope, exceeds 4 pi, just by a little bit, but that's enough. So I can discard that and stop here and say that these are the two solutions for this equation.